Alrighty everyone, we've come to day 13, which is a distress signal. You do have lists and numbers and they can be jumbled up in pretty much any fashion you want, right? So you can have a list into a list, in the other list within the list that contains some numbers. The list can be also empty, and yeah, that's how it looks. So we have to parse this, and the important part is whenever you've got a completely empty line, this is a it's a divider between one pair of the packets and the other pair of the packets. The packets are in correct order, and this is what we really try to find out. Whenever you've got only values and the value on the left is lower. If both of the values are lists, then you go inside pretty much and you start the comparison once again. There is one caveat here, that if you have list on one side but the value on the other side, you just wrap the value in the list and try to compare it once again. First things first, as always, let's skip the test for today. Why not? So we've got the packet part. This is how I see it. Packet part is something that will always be either the list of values or the value itself. This type alone actually is more than enough to get us through all the possible nesting here. The other thing I did is the packet pair. We always compare a pair of packets, right? We've got the left and the right packet, and we always compare those two. So for the fault accumulator, I actually could have used a tuple, but since those are two integers, it's just, for me, it's just so much more readable when I have the names for those integers, right? So we've got value index and bracket counter. You'll see where that is used. To have it so much more verbose, I do have a comparison result. So we either have the correct order, the incorrect order, or not decided. Get sum of packet indices in correct order. What we produce is the packet pair list. Since we do have already the left items and right items, we can compare the packets and get the order out. So either a correct, incorrect, or not decided, right? Probably the most tricky part in here is really reading the input. We split by two new lines. Then within the map, we can actually read the packet pair. And packet pair, once again, is split by a new line, and then we read a packet part. Whenever we're reading the packet part, we're reading the input as a string. So one of those strings that we can get would be this. And this is an empty list, so whenever you see this sort of input, you just create an empty list of values. We can have a very simple value. And this is exactly the second part of our matching. So whenever the string does not, and bear in mind this is push to not, it does not contain a bracket, opening or closing bracket, or it doesn't contain any commas, it's a straight up value. Whenever we've got a string that is not just an empty list or a very specific value, we go into this third part of matching, and that begins with divide string. So let's go. Inner divide in general will divide the input into smaller chunks. It will remove the comma, but it will remove it smartly. So it will divide the input for those two. Yeah, exactly. So it will not remove commas from this inner list here. It will just remove the comma that is actually meaningful on our level. So this is the main job for inner divide. If we have this sort of input and we throw it into inner divide, it will actually return the same thing. Well, the same thing as a list, really. So once again, if the input is actually only one thing in the list and it's actually like equal to the input, then the input was a single list, and then what we do is strip the input of the first and last character. So this is the input without list brackets from the very end. And that thing is thrown once again into inner divide. So now, as I promised, let's go into inner divide. It will count open brackets and closed brackets, and it will also split by commas, but only when it does make sense. So what will actually produce would be those strings once again, not values per se. Alright, cool. So we've read the values. Once we've read the values and we've got the pairs, it's easy peasy. So we just have to include the rules that we've seen. If we are comparing two values, if value left is lower than value right, this is a correct order. If the value left is higher than value right, it's an incorrect order. In any other case, so if they are equal, it's not decided, just move on. So whenever once more we've got list of values with the same length, what we do, we zip them together to have them as pairs. We do a fold, because we are running through the list of values like one by one. But if it's not decided, compare whatever is the next values in the list. Both values are list, compare the first values, If the left list runs out of item first, the inputs are in the right order. So we're here. The left is shorter than the right. We still have to go one by one through those items for the common length, let's call it that way. We cut the right list here to build a new right, this one. Then we once again run compare packet order, and this is the current output. If it's already correct order, then just return correct order. If it's not decided, that means left side run out of items first, so this actually goes into correct order now. If it was incorrect, it still is incorrect. I'm sure you can imagine the situation is quite similar, so this is the opposite example when the right list is shorter. What else do we have in here? Yeah, if we've got list of values and a value, then we just wrap value into a list. Okay, cool. Let's go back to part number 2, because that's actually it. We're done. Part number 2, we don't care about the pairs. So we have all the packets together as one huge list. Then we add to this big list 2 additional packets, which are called divider packets. We use the same rules, and the whole idea is that we have to organize all of the packets now in correct order. So what are the changes that needed to be made? So get decoder key. What I did after reading the input, when I got the list of packet pairs, I've taken out the items, the left items and the right items, and then I created one huge list of packets. So what we have is the divider packets and all the input packets. Then we run a fold, which pushes through the fold the current order, or the new list that we build. The new list, if it's empty, just add the new packet. If it's a single value, do a simple comparison, add the new packet either as last or the first. If it already has at least 2 items, then you do 2 things. First, try to place the packet at the very beginning, and if that doesn't work, we go through all the pairs. So we go through the pairs and we try to fit in that new packet. What we get in return is 2 things. So first of all, we do get a new order, or the new output. And the output, yeah, you have to flatten it because it's a list of lists. So this is what we do in here. and we also have the new packet already placed. But to that output we also add the last element because of that pair processing. Yeah. If the new packet was already placed, we're golden. If it was not placed, place it in the very last spot. And that's it. Since you have every packet now in order, we can easily grab the divider packets and just multiply their indices. Alright, perfect. Thank you very much, guys. I'm happy you've been here, and as always, we can do better as a pack. Bye, everyone. Yeah. How do I do this without... I just... I've taken them out. Yes. Alright, everything plus decoder packets. Decoder? Divider.